Right, Rough as Guts Productions moves on to another week, week 8, program style and design. So this is a bit of a change of pace. We're going to talk about, not so much as we have in the past, talking about details of Python and what you can do with it. We're talking about the larger scale software design problems, how we build bigger programs, how we build software that's manageable, maintainable, and essentially this is kind of an introduction to some of the key concepts of software engineering. So the topics covered in the whole week, talk about program style, an introduction, that's what I'm going to do with most of this video. Then later on we'll move on to issues of functional decomposition, how you break a large program down into smaller manageable pieces, how we design programs, a very challenging question altogether, and then we'll go back to talk more about style. So the reason that there's a bit of a break here is that the lab this week is focused on functional decomposition, so we move quickly onto that, then we go back to talk about the more general issues. So this particular video, I should say, is going to talk a bit about what style is, and the slide tells you it's the way in which something is done, said, expressed or performed. It's a sort of informal concept. We all have an idea of style, what is nice, what isn't nice, and it's somewhat subjective. What some person thinks is particularly beautiful dancing, another person might think is a particularly poor style of dancing. It depends on what you're used to and what spins your wheels, whatever. However, there do seem to be some fairly common themes, and I hope to explain or show you that with some entertaining examples from the past of what I consider bad style, and I think most of you will agree with me. So in programming in particular, when we talk about style, we're mostly concerned with whether you can read the code, and a strongly related concept, whether you would be able to maintain the code. So if you can't read the code, you can't maintain it. So a prerequisite for maintainability is that it's readable, but there are other issues as well, such as whether or not if you change the requirements a bit, it turns out the design is kind of locked into one particular set of assumptions and you can't modify it usefully in any way at all. As far as COSC 121 concern goes, the focus in style is talking about firstly whether it's correct, and secondly whether it is nice code. So I'm not concerned with the issue of efficiency in COSC 121. You will talk a lot about that in 122, but as far as 121 is concerned, we're not dealing, for the most part, we're not dealing with problems which should run out of, which may run out of time if you are not careful in the code. So I'm going to teach that for 121 purposes at least, you don't worry about how efficient your code is unless you have already discovered that you have a problem and then you have to deal with it. And it's always the case that slow right answers are better than wrong fast ones, something that some people tend to lose track of. And even if you're writing one-off hack code, I just got to solve this problem, it generally needs to be readable and correct. Otherwise you probably won't even get it going in the first place if it's not what I call clean code. So what I want to do for the rest of this is demonstrate a few examples of what happens if you don't have style guidelines. Now, many of you will have got annoyed with Pylint. We all get a bit annoyed with Pylint at times. It seems so pernickety and fussy. But what I would like to show you is what a dramatic improvement we've had in COSC 121 since we brought Pylint into the picture. Prior to that, we told people what they should do, and some of them did, and some of them didn't. So I'm going to quickly run you through some code examples submitted in the past, back in 2013 or thereabouts, before we had Pylint, and I'll show you first of all that we could get good code sometimes. So here's some code that I'm just going to quickly run the cursor over and you can get some general impression, right? It looks okay, it's got a docstring at the top, the functions have got docstrings, and if you run the cursor through or run the scroll of the whole program through, it kind of looks okay. Is that a reasonable statement? I hope you sort of agree. You can see it's broken into functions. Maybe it's a little bit cramped, maybe two spaces. Blank lines would have been nicer, but it's got reasonable identifiers. It doesn't look terribly complicated. It's not very long. It looks okay. Let's look at another one. Same idea. Looks okay. Docstrings, yes. Identifiers look okay. Complexity kind of looks okay. Broken into functions. It looks sort of all right, okay? And here's another one. This is a particular problem it was called Friends at the time. It was, I think, a variant on the game Othello. Some of you may have met that. Or Reverse I. There's various versions of this game around. And this was a somewhat larger problem. than the other ones, but if we scroll down you can get some idea that it still looks kind of okay, right? This looks like the sort of code you could pick up and work with. Now I'd like to do the same with some code that I don't think you'd be so keen on, and I'm just going to first of all run the cursor down a couple of examples without comment. Maybe I will comment, maybe I won't be able to stop myself, we'll see. So here's a piece of code that, oh, it looks all right for a start, so let's just see what happens as we run down it. So hopefully you notice something about that. What you may wish to do at this point is pause the video and make a few notes to yourself of what you think has gone wrong with this program, what's wrong with it, and I'm going to do the same with another one. So again, you can pause the video and then we'll come back to these. So here's a second example of the same problem. I call this one Bad Friends 1, this is Bad Friends 2, and see if there's a different set of problems here. See if you can pick what you think might be wrong with this one as opposed to the previous one. So we're at the beginning of it now, and I'll just quickly scroll through it. This was a very subset of the problem. That particular student didn't get so far, but hopefully you noticed certain errors and wrote them down, and I'll come back to them in a minute. Here's a different problem altogether. Again, look at it and see if you can tell me what you think is wrong with this one. So all of those, of course, didn't have Pylint. There was no way either any of those three would have been Pylint compliant. So again, if you've made a little list, let me see what my impressions are and see if you agree. So the first bad example I gave you started off well, and when we got down to around about here, it kind of started to think, ooh, that looks a little bit odd. Look, well, if something, if something, if something, if something, if something, return else, 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 else. That kind of doesn't look quite so good, and as we move on, it all kind of falls apart. So the code gets very complicated round about this point here. So we've got a piece of code, and if you try to work out what it's doing, if y is 0, then if x is 0, then do that. For y and that, for row and that, for space and that, if that. So this piece of code here is executed only if y is 0, x is 0, and it's executed every time for every row and for space in each row, whatever that's doing. So it's every column, I assume, and then only if space is equal to the other player. So it's a very complicated piece of logic to get to that line, and from then on this sort of it just continues. If x is z, we've got a whole heap of stuff. So trying to work out what's going on here is extremely difficult. And this is all one function, so that the length of that one function, and that's not even the longest one, is certainly way outside the levels that we're regarding as reasonable in Pylint. So here's an, I think, even worse one that starts at line 389 and carries on to, with horrendously complex logic, carries on to 389, still going, 389 to, whoa, this is quite a function, right? 390 to 709, so that's for 348, if my arithmetic's correct, lines of code in one function. So hopefully you realize that's pretty bad. This one has a different set of errors. I mean, there's no doc string at the top, there's no doc strings anywhere, in fact. We've got this obviously weird piece of code to initialize the board. If it's a size 4 board, you initialize it like that. It's size 5 board, you initialize it like that. It's a size 6 board, and so on. Clearly missing some simple abstraction. All of these answers only have an O and an X and an X and an O in the center, so it could have been computed via a very simple algorithm rather than special casing all the code. And again, no doc strings. Weird code like alphabet is A, B, B. It looks like this student is missing some generalities, simple abstractions. And they didn't get far with the problem either, which is they tend to go hand in hand. If you can't see abstractions, ways of doing things more neatly, then you're in trouble in programming. I should mention this is Python 2, not Python 3. And then bad clobber. This one is so appalling that it's, I don't know where to start. No docstrings, no white space. We use one character white space indentation. All the identifiers are ghastly. It's got multiple lines of code. Working out what's in there is very difficult. It's just, it's sort of almost a classic example of appalling code that nobody could even begin to understand what's going on in that mess. And probably the student, him or herself, couldn't figure it out either. So I would be very doubtful whether that got too many marks. So hopefully that's enough to convince you that Pylint, when we brought Pylint in, we did actually take an important step in the right direction. So compared to this sort of code we're just looking at here, the code you're all writing nowadays is just wonderful because Pylint won't let you submit rubbish like that. Lastly, one thing that's worth a look, which is kind of fascinating, is this one called Monster Assignment Submission, which is a record breaker. So let's, again, no docstrings, but let's start scrolling down this for a bit and see what you think. So I'm just going to drag this down. So, it's getting rather, perhaps I'll take it down a bit more slowly. We'll come down like this. We're scrolling fairly quickly. You'll see we're up to lines 1700, 1800 now, and we're still going. We could stop somewhere and look at a piece of code. If A in A9 or capital A9 and B in that, then do that. Else, if that, this is all one if statement here, goes on. This is one 3-line, sorry, it's a huge wide if statement in one line. So that's one line expanded into 4 there on the screen. And it's interesting to us, it's one of the more fascinating pieces of code we've ever received. This student doesn't know about loops. So if you've got an 8x8 board and you've got to move from one square to another square, then what do you do if you don't do loops? Oh, well, maybe you say, if I'm moving from this square to this square, then here's a piece of code. If I'm moving from this square to this square, here's another piece of code. And that's 64 squared possible moves, right? You have to check which one it is. So that student has gone through and expanded all the moves out in wondrous ways. Actually got some marks. And we were so fascinated we had to invite the student in to come and explain what they'd done. They were quite indignant that we didn't like their code because they spent so long on it. It was such a big job. And, well, yeah, but sorry, mate. So look at this here. If A and D6 board line 6 equals to be moved to, I can't see what the difference is there. Lack of, oh, that's assigning the different destination in each case. Okay, so this is what really, really, really bad code looks like. Absolutely monstrous. It runs on to a grand total of 16,222 lines. So please don't do that. Please figure out how to use for loops or generalities, abstractions as it's called. Okay, hopefully I've convinced you at that point that good style matters, that if you have bad style, if you have bad code, there's no way you would want to pick that code up and manage it, or pick that code up and fix it if it has a bug. What chances do you have? And I'll call it quits for this particular video. I hope you've enjoyed it. See you in the next one. Bye.